I'll be discussing a little bit about ECG signal processing. Probably one of the signals which has been most exploited in this world, in the human body, is electrocardiogram. Obviously, after the pulse rate. In many of the films you must have seen, the doctor comes, simply puts the stethoscope and declares the patient dead, and then the music starts, the family members weep and so and so. This was an old legacy. Later on in newer films, now things have changed a bit. You see a patient lying on the bed, there is a bedside monitor, and this monitor is showing an ECG wave which you can see in my back also. And suddenly this wave becomes a straight line, and then again everybody leaves and the music starts. So we have also come a long way in films from pulse rate to ECG. The display which you see on the bedside monitor is electrocardiogram. So we have also come a long way in real life as well as in the real life. But because I have started from the real life, so we will start like this. So, contrary to the prevailing poetic belief, the heart is not a place of stay or worship. Okay? Not a commodity of exchange. दिल ले दिया ऐसा कुछ नहीं है. Okay? कोई दिल में आकर नहीं रहता है. Nothing like that. And it's not an organ meant to wish, say or compute logic. Like दिल ने फिर याद किया, दिल याद नहीं करता. In fact, so human heart, everybody knows where it is located. It is located inside the thoracic cavity and slightly towards the left side. If you look at the size, it is the size of a closed fist. हमारे मुट्ठी के बराबर size होता है. And the heart contracts rhythmically to propel blood in the entire body. Heart is probably the only organ which works mechanically even before birth till birth. And with the changed definition now, in which in India we say a person is dead when the brain is dead. So the heart may beat even after death. So when such a powerful machine is there and it beats continuously, but due to its arrangement of cells, molecules, so the heart muscles, they rest only for a fraction of a second between two beats. But one thing probably you must have noticed, in our life there is a point when the heart stops. Even if you are alive, your heart stops just for a while. In which condition?
Sure.
No. Sneezing. Very good. Very good. When you sneeze, all the muscles in the body, they contract. And in this time, what happens? The heart muscles, they also contract. And when they contract, they flush all the blood out of the heart, and for a while they stop. Then what happens? Subsequently again, the atria fill with the blood, then ventricle and so on. So let us calculate now over a typical lifespan of 76 years. The heart will beat nearly 2.8 billion times and move about 169 million liters of blood. No machine in this world so far has worked for so long and in such a big quantum without proper maintenance. It is only the human heart. So you can see how great engineer the nature is. So this is our heart. All of you must have been studying it since childhood. So you can see in the blue color we have represented the organs, the veins, etc., where impure blood is there, and the red color is indicated the pure blood. So you can see from the right side the impure blood or deoxygenated or carbon dioxide enriched blood enters into the heart. It enters into the right atrium. From right atrium it goes into right ventricle. Right ventricle pumps blood into pulmonary system, and it is pulmonary artery which takes blood from right ventricle to pulmonary system. In pulmonary system we have the gas exchange, means carbon dioxide is liberated and oxygen is mixed and hemoglobin mixed, oxyhemoglobin, and then this blood enters again in left atrium. From left atrium it goes down the left ventricle, and left ventricle contracts. Left ventricle is probably the most robust structure, and it pumps the blood into the entire body through aorta. So in this entire cycle you must have seen that it is going to be very long, but it's not. In fact, what happens? Both the atria contract together and they fill both the ventricles together, and both the ventricles they collapse together and take the blood out. So this cycle is reduced. Instead of having 4 strokes, now we have only 2 strokes. First atrial contraction, and when the ventricles contract, in this duration the atria starts filling up again, and so and so. So if you see any film in which you can see an open heart, you will see that it is like that, it is pumping from this side and enlarging from this side and collapsing from this side, enlarging, and so and so. It is very rhythmic. And the same thing you can listen with the help of a stethoscope, or you can observe in an electrocardiogram. So we all know, we have already taken up this thing, and this is the cardiovascular system. You can see again that in our entire body there is a mesh of arteries and veins. Veins take the blood towards the heart, and arteries take away the blood from the heart. So you can see in red color it is arteries, and in blue color it is veins. But there are few arteries and few veins which do not follow the oxygen carrying and carbon dioxide carrying this phenomenon. Like the pulmonary artery, it carries impure, means carbon dioxide mixed blood, and pulmonary vein contains the pure blood. So in broad definition, one thing is true: veins take the blood towards the heart, arteries blood takes blood away. So now we move further. The history of ECG. Now we have gone to the electrocardiogram. What happens? All the muscles in the body, they usually remain at -90 millivolt. They usually have an ionic exchange system in which their membrane, cellular membrane, it is having semi-permeability. So it permits only selectively, and it permits only, let us say, potassium ion or sodium ions through certain channels. Okay. So we can say that if an equilibrium is established because of the variation in the concentration, what happens? That inside the cell, the potential is minus 90 millivolt and outside it comes out to be plus 90 millivolt relatively. Okay. Then what happens if somebody triggers a cell? Then what happens? The cell contracts and its potential rises to plus 30 millivolt. So what will happen? If a cell is in excited state or it is in working state, its size will be reduced and as well as its potential will increase. Now, if the size reduces, then what happens? How our hands and legs etc. move and work? It is based on this. If you permit me, I will draw it on the board. Let us say if this is your bone. And let us say this is a muscle cell which has connected both the bones. Let us say its length is L. Now, under an impulse, if this length is reduced by L by 10, what will happen? Because this part is hinged. This is well connected. So, the only angular movement is possible. So, what will happen if this bone, let us say, is fixed? Then what will happen? This bone will have an angular movement, and so what will happen? It will be reaching like this. And this is precisely what we do every day. Hands are like this, my hand is stretched, and so what is happening? The muscles connecting both the bones, they are stretched. Okay, but as soon as I give a signal that now pull, then the hand will be moving like this. So biceps, they will be used for bringing the ends closer, and triceps, the lower side, they will be again flexing the hand back. So this is the function. So the same thing happens in the heart also, that a heart, ventricle or atria or anything, it is again a combination of different types of cells. So if all the cells they contract, then what will happen? The area, surface area will be reduced, and so the enclosed volume will also be reduced, and this is the phenomena by which the heart pumps. All the cells they contract, and so on. So this is a little bit of physiology that is necessary to understand why electrocardiogram is generated. People knew about electrocardiogram long back, that yes, there are some electrical activity in the heart, but it is only in 1903 Professor William Anthony recorded electrical signal from the heart. He had a dog named Buddy, and what he did, he had 4 buckets of this saline solution, and he put his dog in such a manner that each limb gets into one bucket, and then he connected the buckets to a string galvanometer. He designed a string galvanometer which could measure millivolts, and then he found that string galvanometer was having some rhythmic movements, positive and negative. Getting excited by this, he had a mercury type of measurement, and then he tried to record an electrocardiogram. So in 1903, he was successful in recording the electrical signals from the heart. and that's why it's called electrocardiogram. And another landmark came in 1957 when Pipberger started ECG analysis by digital computer. Digital computers had come into the, you should say, use in 1957. The ECG signal was digitized and used by Pipberger, and he started this. Broadly, we should say CSE Working Party recommended two major things. One is that whenever you record an electrocardiogram signal, then you should be able to have a minimum measurement level of 5 microvolt. Means you should be able to measure at least 5 microvolt. Your least count should be like that. And the sampling frequency should be at least 500 Hz for an electrocardiogram. Why? So we will be coming into this later. Until date, implementation and conformance of CSE standards are underway. Now, this is something very strange thing, but business goes its own way, research goes its own way. People, in order to have superiority over their competitors, they want to add certain features and try to make their product exclusive. CSE Working Party wanted that we should have conformance to some standards so that there can be interportability. But most of the manufacturers do not want it. So still, there is not a proper agreement amongst the manufacturers of electrocardiogram machines, and so the implementation conference is still underway. And the irony is, above all, many countries are having their own standard database, but in India, still we do not have any Indian standard database. So what is happening? We are still following the European standards, and European people and Indian civilization, they vary a lot. If you have the chest measurement in cardiothoracic measurements, then you will have the ratio of the chest measurement to size of heart higher in European people and lesser in India. Our chest size is comparatively smaller. Also, the fat content in our body is somewhat less. As a result, being an electrical signal, it is available more on the surface. Its attenuation is less, so voltages are low. As a result, what is possible? That a person of Indian origin who is not having any cardiac ailment may be considered abnormal as per the European standard. So it is possible that we may declare somebody ill by that standard, and vice versa also too. We may declare somebody fit even when the person is having a disease. So it is very much necessary that we should have our own Indian standard database of electrocardiograms. But you know, India is a big country, having all possible varieties. We have different types of habitats, different types of habits, different types of people, varying in size, shape, etc. everywhere. So, having a common standards probably will take again years together. So now we again come back to the electrocardiogram signal. In this diagram I have tried to show you how many factors can affect an ECG signal. All these things, they all are connected to each other one way or the other. Like we start from the renal system, the kidneys and the extraction tubes. renal system is connected to the cardiac system. From the blood, we extract the urea and other unwanted components. So, renal system is affected, or it affects the cardiac output. Cardiac output affects the vascular system. Vascular system means the movement of blood in the body. It affects temperature and blood pressure. If the movement is faster, then what will happen? Your temperature may go high. And in order to control the temperature, what happens? That your glands on the surface, they may have some perspiration coming up. At the same time, if you are having your vascular system having more pressure than your blood pressure, which you measure from your femoral artery, it may also go up. And all these things, they affect the autonomic nervous system. Autonomic nervous system is the nervous system which regulates our this myocardial contractility, means heart's rate. It connected to sinoatrial node, and so heart rate is governed, and so and so. And moreover, it is the electrocardiogram signal which is ultimately gets affected. Similarly, the oxygen concentration in the blood, or partial pressure of the oxygen and partial pressure of carbon dioxide, they also get affected. Let us do one simple experiment. Do measure your heartbeat for a while. Okay. Not now, you can go near hostel, you can do it there also. Okay. Write it down, how much it is. Then do one thing. Ask somebody to whom you trust. Close your doors and do not breathe for about half a minute. Your partial pressure of oxygen will be falling slightly, and partial pressure of carbon dioxide will be raising slightly in the entire body. You will be having some uneasiness, but at the same time, if you try to measure your heart rate, you will find it has gone very quickly. And because you trust the person, so please ask him to do it now. Because a little longer, and next day will be a holiday. Okay. So, what I want to say, that whenever there is some change in the partial pressure of oxygen and carbon dioxide, our body demands change. And as a result, again, everything changes. Sinoatrial node changes, heart rate changes, and ECG signal changes. And even, let us say, if you are having too much of perspiration, even then, heart rate will change. If you respire too much, even then, your heart rate will change. You can do yourself. Take a deep breath, and at the time you measure your pulse rate. Then exhaust the air completely. Remain in that state as long as you can sustain, and then you measure and you will find the difference. So all these things, they affect. Even if I tell you that all of you are getting your TA right now, your heart rate will change. And if I immediately tell you that leave this place, within 5 minutes there is going to be an earthquake, again your heart rate will change. So electrocardiographic signal, they gets affected by almost everything in this world. Even Sensex gets down, the heart rate gets affected. And when you listen that America has bombed Pakistan again, even then your heart rate will change. Okay. And again, the bottom line is individual cardiothoracic dimensions. They also affect the signal on the surface. ECG signal is being picked up on the surface of the human body. So, any change may affect the electrocardiogram. So this is much talked about signal, the electrocardiogram signal. And as we have already studied, that it is rhythmic. There is a set rhythm in which we have first the P wave. When auricular atria they contract together, there is a P wave. Then there is a QRS complex. We call it QRS complex because earlier it was not known. From which part Q wave will be appearing, from which part R will be appearing, from which part S will be appearing. And so, combined they call it QRS complex. It is because of the ventricular contraction. And then we have T wave. And after T wave, people used to say that now the ECG cycle is over. But it never used to be the case. Later on, people realized that there is a U wave also. So, in this TP segment, there is one more reflection that is called U wave, and very recently in 2006, Professor Retsema van Eyck from Netherlands, he solved this mystery of U waves, and he said that U wave is because of the late repolarization of M cells, deep-seated myocardial cells, and because of that the U waves do appear. And after U wave, obviously we say for the time being that the heart rests till the next P wave comes. And electrically, if we speak how the charge moves down, then the sinoatrial node is the node from where all this charge starts. A pulse of charge starts, it goes into atrial pathways, means there are three pathways which surround both the atria, and through which the charge moves to atrioventricular node. From atrioventricular node it goes to bundle of this and then to Purkinje fiber. I hope this much of physiology I think everybody must have studied in the initial level of your schooling or somewhere. So I do not need to give much emphasis, but just always keep this thing in mind that whenever we are analyzing ECG signal, we should always correlate from where the signal has originated, from where the signal has come. So at the time we need to remember all these things, then only we can go for proper classification. Now a classical question: electrocardiogram versus electrocardiogram. Many people cannot differentiate between these two. Even a few cardiologists I asked. The electrocardiograph is basically the machine. The machine that records electrocardiogram is called electrocardiogram. And electrocardiogram is the record we obtain of the machine. But here again, the bottom line is that electrocardiogram gives the static condition of the heart, and that's why it should not be considered a sine qua non for any disease. What does it mean? If a normal person is there, it's possible that because of certain reasons, we'll be coming on to reasons also, the heart may show an abnormal ECG as per the prevailing standards. And for an abnormality in the heart, even in the presence of an abnormality in the heart, it's possible that the electrocardiogram will be normal. So, ECG should always be correlated with other findings or other ECG independent tests. Nowadays, people go for the treadmill test also, people go for the ultrasound. There are so many things. So, a lone ECG should not be considered as the final diagnostic tool for heart disease. If you have any question, you are always free. The communication should be two-way. Okay, else you will be feeling drowsy and will be going to sleep. So please do ask.
Sir, how that ionic charge is converted into electric signal?
Okay. You know what is ion?
Having a charge, positive or negative.
And whenever a charge moves, what happens?
Means positive will combine with negative.
Pardon?
Positive will go towards negative.
No. Whenever a charge moves, what happens?
Current.
Yes, current. And whenever there is a flow of current, there will be definitely some impedance in between. This world is not free from impedance anywhere except superconductivity. So, whenever there is a flow of charge, there will be potential.
And how is it actually measured? It is in the muscles.
That's why That's why I'm coming on to this. Any other question? Okay. ECG signal is quite feeble and is in the range of around 1 millivolt. Now I'll answer your question. We're told that at rest the potential is minus 90 millivolt. But when the cell is excited, how much? It is coming out to be around plus 28 millivolt. So all these things are happening inside. If you put electrode over there, then what will happen? You may be able to record the exact voltage. But then what is happening? Above that musculature, you are having pericardium. Then you are having various layers of fat, muscles, then bony structure, then again fat, then you have this epidermis, then dermis, and so and so. So what is happening? What is coming up? Just, you should say, little bit of reflection, little information. So you can say that the potential which was inside, it has greatly been attenuated and only around 1 millivolt is appearing on the surface of the body. So it is the medium that attenuates this signal, and so on the surface we have. Then, for the light of electronics engineers and electrical engineers, we come on to the bandwidth part. The clinical bandwidth of ECG signal is 0.05 Hz to 100 Hz. This is perceivable by human eye also. If you have microwaves, if you see the microwaves, you will not be able to see anything. You will need good amount of instrumentation to decipher it. Even acoustic sounds, acoustic waves, even acoustic waves which are longitudinal in nature, you will not be able to see anything. But in ECG, which we plot in the transverse fashion, and this clinical bandwidth is to 100 Hz limited, so you can see. When I started my lecture, the very first time you had seen a plot going like this. So its frequency matches with our eye, so you can see it. And it may be picked up from standard locations. We are having two systems. One is the Frank lead system, or we call it XYZ leads. Again, it is an engineer's delight. We try to resolve all the vectors in this world into 3 dimensions: X, Y, and Z. So, Frank lead system is much more popular with engineers than with doctors. So, initially, the people who started working on computed electrocardiography, they tried to popularize the Frank lead system, but the clinicians did not approve it. So they are still staying with the standard 12 lead system, and ultimately we have also joined the band. Okay, chalo koi baat nahi, hum bhi 12 lead system pe kaam karenge. So nowadays 12 lead system is still much more popular than the standard Frank lead system. But whatever be the case, for both the systems, the ECG ECG can be taken up from some standard locations on the body. What these standard locations are, we are coming into. And as we already discussed, that instead of having a front lead system, we have a standard 12 lead or 12 channel system. Now the thing is, CSE working party recommends that there should be simultaneous data acquisition for a detailed QRS system. It should not like that you record one lead first, one channel first, second, and so and so. It should not be in series. Rather, they all should be parallel. जबकि आपने कभी किसी ने डॉक्टर के पास ECG करवाया था? Has anyone gone through?
No.
Electrocardiogram? All of us were lucky. Usually, you must have seen somewhere that they record one lead first, then they ask the patient to wait, change the lead, then we record the other lead, then ask, wait, third lead, then AVR, then AVL, AVL, then V1, V2, V3, V4, V5, V6. So it takes 12 steps. But in computed electrocardiography, it is recommended that all these channels they should be scanned together and should be recorded simultaneously. So that what is happening at one instant in one lead should be corroborated with the corresponding state in the second lead, third lead, or in any other lead it is appearing. Okay. Like very simple example, you all must be watching nowadays cricket. Cricket is probably the most high-tech game today. Instead of one, they are having multiple cameras. So let us say Sachin Tendulkar has been given out leg before wicket. Okay. Then all the Indian fans, they will be feeling very restless. How he has been given up? He was not. He was not. Okay. Then the TV cameras they come up. They show you that yes, these are 3 stamps. This is the line, and where the ball has fallen, and now you can see the Hawkeye projection, and where the ball will go. Now you can judge whether the umpire was correct or not. So it is only because of the multiple camera you can see. Okay, they have created a 3-dimensional picture and biogenes. And even a simpler cases are announced. From one side, let us say the camera view is blocked by, let us say, the umpire's back. You can't see when the batsman touched the ground and when the ball is got down. You take another image. And here again you are unable to see whether the bat is touching or not. Then you can go for the third angle. So when all these cameras they are recording simultaneously, then it is very unlikely that you miss any event. And even if one camera is recording one event, you can confirm it with subsequent cameras. Same thing happens in electrocardiograms. If something is coming up in one lead, simultaneously it will be appearing in other leads also. So it is basically, you can see, a representation taken simultaneously or at the same instance. So now we have studied the ECG wave components, so let us again talk about them. The P wave, it is usually less than 0.5 millivolt and its frequency range is 0.1 Hz to 15 Hz. Then where the P wave ends and QRS complex begins, we call it PR segment. It is very small, of the order of 0.1 to 0.12 second. Then we have QRS complex. The Q wave is generally less than 0.3 millivolt. R wave is generally less than 2 millivolts, and S wave is also less than about 2 millivolts. Their frequency range is considered to be within 10 Hz to 60 Hz. ST segment, the elevation should not be more than 0.5 millivolt. T wave should be again less than 1 millivolt, and TP segment should be nearly 0 in the isoelectric zone. You must be finding that this is something very glibbish. Okay, you are unable to understand this. But I thought that probably some of you must have had some background of this biomedical signal processing or biomedical engineering. Has anyone studied biomedical in the graduation? None? Okay, no problem. So I'll straightforward come on to the lead system, ECG lead system. With pictorial presentation probably you will be able to understand better. I think all of you know what is the single-ended signal acquisition and differential signal acquisition. You all know? Against one reference, if you are measuring one voltage, we call it single-ended. But not taking the reference into account, if you are having, let us say, two signals, and both the signals are when subjected to one same amplifier, and we try to find out the difference, we call it the differential, isn't it? There is one common ground, but let us say there are two signals coming, let us say E1 and E2. Then when one signal is given at the minus of the amplifier, one signal is given at the plus of the amplifier, then what will you be getting? You will be getting the difference of them, we call it the differential. Okay. So if something is with respect to ground or zero, we call it single-ended, and if something is with respect to the other signal, we call it differential. So in limb leads, we have two types of measurement. First is the differential measurement of leads, or the first group we call, in which what we do, we take signals from arms and legs. For that, what we do, we usually ground the right leg. Right leg is connected to the ground of the machine. And then one electrode is connected to, let us say, right arm, the other electrode is connected to the left arm. And then both these signals, they are subject to amplification and signal processing, and then you can see the difference. So this configuration we call it lead 1 configuration, in which we connect the left arm to positive terminal of input and right arm to negative terminal of the input, and so ECG signal is obtained. This is such a simple thing. To obtain an ECG signal, you do not have to go for anything special. You simply connect two electrodes, hand in hand, both the hands, and you will be able to get the signal.
Electrodes.
Okay, I will come to electrode also. This part actually I have not covered over here. The ECG signal is available on the human surface. This we have already told. Now, how this signal is to be obtained? We know that the human body in itself is not a good conductor. But the signal is somewhere located on the surface. So what we do, on some part of the body which is having usually some porosity. If you see your hand, the back of your hand or any part of the skin very carefully under a lens, what you will find? That there are some pores. If these pores are filled with some electrolyte or some charge carrying material, then you can make it slightly conductive. So what we do, on this skin, we have one interface. It is basically a jelly made of silver chloride. silver and silver chloride. Gel is there. So you put this gel over here. And then on this we have an electrode also. This electrode is also having silver chloride coating. It can be a copper or it can be a silver electrode on which you have coated silver chloride so that you make it homogeneous. And then you have a knob, and this knob you can connect to an external wire. Okay? So if you connect this type of thing on the left, if you connect same thing on the right, and you connect it to a, let us say an oscilloscope, you can see different things coming. Try it, you will find it.
One thing, sir, voltage comes by the use of induction or conduction with the electrode.
Yes, it comes.
By the induction or conduction. My question is, voltage comes through induction or conduction by the use of electrode.
It's not like that. Let us say this is something in which there is a dipole, and in this area you are trying to measure voltage at this point and at this point. If you connect it to the voltmeter, will you be getting some voltage? The same thing. Usually, we are not being able to visualize the effect of charge, how it gets converted into voltage. This body looks like a capacitor. Some charge is moving inside, and because of this voltage is appearing on the surface. But it is because of the physiology that different potentials appear at different places of the body. And as a result, what will happen? We are simply measuring the difference of these voltages. That is electropotential. Could I make it clear? Or is there still some doubt? Try to visualize yourself. You can also see. You can connect electrocardiogram and you will be able to see. So this was about lead 1 configuration in which we had connected left arm and right arm in this patient. Now instead of left arm, if I connect the electrode to left leg, at the bottom you can see on the diagram also, if you connect it to the left leg and the negative electrode is connected to, let us say, the right arm, this configuration is called lead 2. Lead 2 is one of the most exploited signal, because in this case what happens, the R wave amplitude is maximum, and so it is often preferred to measure lead 2 for the purpose of your recording, whether the patient is alive or not. We usually go for lead 2. Then lead 3, in which again left leg is connected to positive and left arm is connected to the negative, and so you have a triangle also made like this, and this is the polarity cycle also. Left leg is considered the most positive. Left arm is considered a little lesser than left leg, and right arm is considered the most negative. So when you are measuring voltage in this fashion, then what will happen? You can establish a triangle in which what is happening? Lead 2 equals algebraic sum or vector sum of lead 1 and lead 3. So if you have measured lead 1 and lead 2, you can derive lead 3 also. Then people found that no, it is still not clear. Still, with the help of the electrocardiogram which we obtained from these 3 limbs, it is still not so clear. We need some more leads to be connected. So, having the electrodes in the same positions, left arm, left leg and right arm, we have developed a new method that we connected one electrode, let us say, to the location, and we took the sum of the other two or the average, and then we have tried to find out. Means you have to measure, let us say, potential in 3 places, from 3 places. Then what you are doing? Earlier you were measuring like this. Now what I do for left arm, sorry, right arm, I am doing a summation of this, and with respect to this I am trying to measure the potential of right arm. So I am connecting the sum point to the negative terminal and connecting right arm to the positive terminal, and so again we are making a measure, differential measurement. In the case of left arm, again I am changing it so that I am making a measurement from left arm, and in this case I am taking a sum of these two. In the third case, I am taking the sum of right arm and left arm and measuring potential from here. So this way, what I am getting? 3 more measurements. They are called the augmented limb lead measurements. It takes about 3 to 4 lectures in making the concept understandable. Here I am just giving a glimpse of how the ECG leads have been made, and then we will see the recording and other things. So just a background of ECG, then we will be coming on to the signal processing. So these leads, they do have mathematical relationship. Like lead 3, it is a difference of lead 2 to lead 1. Then augmented lead from right arm, it is having relationship, it is minus half of lead 1 plus lead 2. Then augmented lead of left arm, it is having this relationship, it is lead 1 minus half of lead 2, and augmented voltage of foot or AVF, it is equal to lead 2 minus half of lead 1. So you can see these 4 quantities we can derive if you have measured lead 1 and lead 2 correctly. So you do not need to measure the remaining 4 channels. So if in a 12 lead ECG, if 4 channels you can derive, you need to measure only the 8 channels. And why we are emphasizing on 8 channels? Because multiplexing we often do on 8 channels. Because we have the addressability in this form that either it is 1 channel, 2 channel, 4 channel, 8 channel, 16 channel, and so on. So if you are having only 8 channels to be recorded, then what is happening? You can optimize your machine's performance. Had it been 12 channel, then you would have required 4 address lines. And still, only you are utilizing 12 channels where you can go for even 16. But you are having only 12 channels to be recorded, so the capacity is not fully utilized. But instead, if you are having only 3 lines, 8 channels, then you are utilizing the capacity properly. So we record lead 1, lead 2 and 6 leads on the chest surface. Okay. And on the chest we have electrodes connected in such a fashion that on the, this is sternum on the body. If you can check with your own hand, in the center we are having one bony structure. This is called sternum, and on the sternum, on the fourth intercostal space, you can see from here clavicle, then you are having intercostal spaces. There is gap, first intercostal space, second intercostal space, third intercostal space and fourth intercostal space. So on the right side, on the sternum, we are having V1, which is on the fourth intercostal space in the right sternum. Then at the same position or same height on the left side, on fourth intercostal space, we are having V2. Then fifth intercostal space in the mid clavicular line. This is clavicle bone. So just in between, in the center, and exactly if I want to define it, you must have gone to a tailor shop. Tailor usually puts the inch tape over your shoulder and let it have a free form. Have you seen? When you go for a stitching of a suit or shirt, okay, he puts the inch tape on the mid clavicular line and let it form. So vertically it is parallel to, or rather it is coincident to your mid clavicular line, and the height is on the fifth intercostal space. It comes out somewhere here. Then it is V4 and V3 falls in between V2 and V4. So you can see in this diagram also I have given it like this. I have tried to make it this inch tape over here on V4, then V3 falls somewhere here like that. Then at the same level of V4 we have V5 and anterior axillary line. This comes out to be somewhere here outside. And just under the arm, mid axillary, you are having V6. So all these electrodes, they are placed on the chest like this. 6 electrodes you have placed and 2 leads you are measuring from lead 1 and lead 2. So in all you are having 8 channels. So this is it. Then we come on to the vector cardiogram or the Frank lead system that measures X, Y, Z leads. So there are so many things with it. I will quickly go through. We will not discuss much. You can simply see the diagram that how this vector cardiogram is measured and how it looks. You can see on the bottom. It looks like this. It's a little bit difficult to visualize also for doctors. Medical students do not perceive it much comprehensively, and so it is not so popular. But still, in Glasgow, we have found they are using it, and many of the programs legacy programs in this automated ECG analysis, they are using this frank lead system because they find it much more easy to compute. But moreover, nowadays, it is the most popular one is the pair lead system.